Hello and welcome to the Physics Shake, work solutions for your everyday needs. Comment, like, subscribe and share. Pause the video and read the question if you haven't already. If you have, then let's get stuck straight in. So we've got a tennis player serving a ball from a height of 2.51 meters, that's there, horizontally at 18 meters per second. So this question, it's about projectile motion, so a good thing to remember is that the horizontal component of velocity and the vertical components of velocity can be treated entirely separately. The horizontal component, if we can ignore air resistance, will stay the same. So the net's 1 meter high, it just clears the net. Show that the ball takes approximately 0.6 seconds to reach the net after being served. So this is relying on us understanding that horizontal and vertical are separate, right? So whatever time it took the ball to get here is the same amount of time it would take the ball to fall this distance, right? So what is that distance? Well, that distance is 2.51 meters minus the 1 meter of the net. So actually that distance is 1.51 meters. Right, so what I need to do is get out the old trusty SUVAT equations, SUVAT. Think about what numbers I actually do have. So I know the height of the fall is 1.51. The initial velocity in the vertical is 0, because remember horizontal and vertical are separate. The final velocity, I don't know. The acceleration is 9.81 meters per second squared. Right, that's meters. And the time is actually what I'm trying to find, because it's a show that question. So the most common equation used is usually ut plus half at squared. Ut plus half at squared. U can be got rid of because, well, this term can be got rid of because u is 0. And I've got all the other terms. The half is just a number, a is here and t is what I'm trying to find. So rearranging s, get rid of the half by multiplying both sides by 2, get rid of the a dividing both sides by a, and then I'll have that equal to t squared. So if I square root that, I will get t. Subbing the numbers in becomes 2 times 1.51 divided by 9.81, and take the root of that, gives me a value of 0.55 seconds. I'm not sure, on the mark scheme they said 0.56, but when I calculated this, maybe it's because I'm going to an extra decimal place here, I'm getting 0.55. But the mark scheme does allow it, so that's acceptable. Next step of the question says calculate the vertical component of the velocity of the ball as it passes over the net. So basically, initially, the ball is only going to have horizontal velocity of 18 meters per second, right? And as it tracks through the air, that component will stay the same, but its vertical component will grow. So say when the ball's here, the arrow here will be the same size every single time. Right, the arrow here will be the same size every time, but the vertical component will get larger and larger and larger due to gravity accelerating the ball in the vertical direction. So we need the vertical component of the ball just here. So again, it's back to the SUVAT equations. I'm going to do it up here because I obviously haven't got space down here. So SUVAT. This time it's still 1.51 meters falling because it's going to fall this distance, and we want to know how fast it's going to be going at that point. It does start at 0. Its final velocity at that point is what I'm trying to find. Acceleration is 9.81 still. T I've actually just worked out, although it's probably not a good idea to use T in the question because it could be that you got this bit wrong. So if you can avoid it, you'd avoid using that T. And when I look at my equation sheet, I see v squared equals u squared plus 2as, and it looks like I can avoid using T just to find v. So if u is 0, this bit doesn't get used. I just need to rearrange for v, so square root both sides. So v becomes root 2as. So it's root 2 times 9.81 times 1.51, times 1.51. And when calculated, this gives me a value of 5.4 meters per second. Okay, so two answers. Next bit. Calculate the overall velocity of the ball as it passes over the net. So in the instant it passes over the net, we just saw, here's the net, okay, the ball comes in, and at this point, so say it starts out here, it's going to have a velocity in this direction of 18 meters per second, and its vertical component of velocity is 5.4, right? So it's actually you're going to have to add these vectors up. So let's do that vector addition. This is 18. This is 5.4. This is going to be the answer. That's the magnitude of the velocity. And this is the direction of the velocity. So I can use Pythagoras to find the magnitude. So it's the hypotenuse I'm trying to find. So it's c squared I'm trying to find equals a squared plus b squared. Right, so subbing numbers in, it's 18 squared plus 5.4 squared, and I'll square root it to get c on its own. Calculating this gives me a value of 18.8 meters per second. So that's this value here, 18.8. And then going back in to get the angle, if I label this up hypotenuse, opposite, adjacent, I have just calculated this value, but again, it's better to use the values given to you in the question. Well, actually, none of these are given to you in the question, but I'm going to use these two anyway. So that's 18 meters per second. This is 5.4 meters per second. I want to try and find this angle, right? So I'm using O and A, so it's tan. Tan theta will be equal to the opposite divided by the adjacent. So tan theta should be equal to 5.4 divided by 18. So when I calculate this number, I've got tan theta equals 5.4 divided by 18. If I take the inverse of tan on both sides, I'll get theta on its own. So theta equals tan to the minus 1 of 5.4 divided by 18. And when calculated, I get 16.7 degrees. Okay, 16.7 degrees. Okay, hope you found this useful. Please comment, like, subscribe, and share. Thanks for watching.